All right, so this video is about word problems and linear inequalities. So you got to write a linear inequality to solve a word problem. This is the first example. It says write an inequality and solve. And the expression says 25 is no more than 8 less than a number. The chart above tells you what these things mean. So no more than is here under less than or equal to. So if I wrote the inequality, it would be 25, change the color there. It would be 25 is less than or equal to 8 less than a number. So it's going to be a number, subtract 8. And you'll solve the inequality. That's pretty easy to solve. You simply add 8 to both sides. So I'm going to add 8 here, add 8 there. So I will get 33 is less than or equal to x. I really rather you write the x on the left side. So x is greater than or equal to 33. Since it's opening towards x here, when I rewrite it, it still should be opening towards x. So the answer for that inequality is x is greater than or equal to 33. All right, so pause the video, get that as a note, and let's go to another one. All right, so here's a new one. It says write an inequality and solve. And the problem says the sum of twice a number and 7 is at most 4 less than the number. All right, so let's come up with that inequality. The sum means that add, twice a number means 2 times x, and 7. So it's going to be the sum of twice a number and 7. That's 2x plus 7. It said is at most. At most is here, and less than or equal to. So it's going to be less than or equal to 4 less than the number. So it's going to be the number take away 4. And that will be the inequality. And we have to solve it. So using that, I could first subtract x from both sides. And I will get x plus 7 is less than or equal to negative 4. And my next step would be to add 7. So subtract 7. So I'm going to subtract 7 from here and subtract 7 from there. So x is less than or equal to negative 11. So that will be the inequality, and now we've solved it. X will be less than or equal to negative 11. I'll get that as a note. I'm going to give you a new one. All right, so I got a new one. This problem says the sum of 5 times a number, and 10 is at least 30. So sum of 5 times a number and 10 would be 5 times some number x plus 10. And it says at least. So at least is here. And that would be greater than or equal to. So it has to be greater than or equal to 30. So at least means it has to be greater than or equal to that number. So let's solve it. In solving that, I'll subtract 10. So 5x is greater than or equal to 20. I need more space in this, so I'll put it here. If 5x is greater than or equal to 20, I can divide both sides by 5. So x will be greater than or equal to 4. So x will be greater than or equal to 4. Any number greater than or equal to 4 will satisfy that statement. All right, I'll get that as a note. I'm about to give a new one. All right, so this one says 3n is fewer than 60. Without even looking up here, let's think about what that means. 3n has to be fewer than. Fewer than means less than. All right, so it has to be fewer than 60. So it can't actually be 60. It has to be less than 60. And if you look up, fewer than is definitely underneath just the less than symbol. So here we are. if I solve this, I'll divide both sides by 3. And I would now have n is less than 20. And that would be it. It would be n less than 20. All right, let's do a new one. All right, so in this one, it says the sum of 3x and 7x is at most 80. So 3x and 7x, as the sum of those, is at least 80. Is at least 80. So let's think about what that means. 3x plus 7x is the sum of 3x and 7x. And let's think about it without using our chart. At least 80. If it's at least 80, 81 is a good answer. 82 is a good answer. 83 is a good answer. So any number bigger than 80 works. And since it's at least, 80 could work too, because it's at least 80. So I know it's got to be greater than or equal to, just by using that wording. And if you look up, at least is underneath the greater than or equal to part. So I know that 10x has to be greater than or equal to 80. Now I divide by 10. And that's an 80, sorry. So that would be x is greater than or equal to 8. All right, let's try one more. All right, so last example. Deja needed $80 to buy a new purse. Her aunt pays her $60 per hour to babysit, and her mom gave her $20 for washing her car. What is the minimum amount of hours she needs to babysit to buy the purse? Let's think about this. She needs $80 to buy the purse, and her aunt gives her $6 an hour, so that's 6x. Her mom has already given her $20, so plus 20, and it says the minimum amount, so we have to have at least $80. So it has to be greater than or equal to $80. So without looking at our chart, we can kind of figure out that symbol has to be greater than or equal to $80. And that's the inequality. Let's solve it. So to begin, I subtract 20. So 6x is greater than or equal to 60. You can divide by 6. And the 6's cancel, leaving with x is greater than or equal to 10. So she needs to work at least 10 hours. That's all I have. Good luck.